Scenario: a student places a block on a ramp with a rough surface and let it go. The block now starts to slide down. I would like you to write an equation to describe the acceleration of the block. Well, here's the answer. First of all, we should label it. The force that's bringing it down is the force of gravity in the x direction. Perpendicular to that is the y direction of the force of gravity. Again, because the force of gravity is downwards towards the center, I just broke it up into its component form. Likewise, this is on a rough surface, so you have force of friction is equal to mu, force normal, but the force normal is Fg cosine theta. Let's write the equation. So summation of my forces, and this is going to be in the x direction, which is force of gravity in the x direction minus force of friction. This equals to ma because the object is moving. Plugging in the values, mg sine theta for the force of gravity in the x direction, mu mg cosine theta for the force of friction. Divide by m to both sides, you should notice mass cancels. If you also see, g was the common like term, so you can factor that out. So here, that is what the acceleration would look like. The last question, what does the student need to measure to determine the acceleration of the block? Also name the lab equipment that is used to do the measurement. I will always tell my students, let the math guide your experiment. You should already have the math here. Acceleration is equal to g sine theta mu g cosine theta. So look at all your variables there. Here's the answer. First of all, it is theta. Theta is the angle of the incline of the ramp. You can use a protractor here. That's what a protractor looks like. You can also write a laser measurement here. That would also be acceptable. Anything that gives you an angle measurement. Also, the other variable is mu, which is the coefficient of the kinetic friction because the object's moving. There's no equipment for that, but how you find that is you would use the textbooks to find a list of known values of the coefficient of kinetic friction, or you could look up it online. Those are the only variables there. G is not a variable. Well, in this case, it's not a variable because this is going to be 9.8, or you can use 10 because it is on Earth. Okay. Always assume the scenario exists on Earth unless state otherwise. So there you go.